can start with some brief introduction once everybody scans their QR codes. Feel free to ask questions there, of course. If we don't have enough time to answer them right away, we will answer at the channel later, as it's customary, I guess. So, who we are. As you probably have noticed, we are from Software Mansion. I am Michał, this is Mariusz.
Hello.
Yeah, we are kind of like two-headed turtle here. And we are gonna to tell you something about pretty common tools in native worlds, native applications worlds, but that you might not be that familiar if you are a React Native developer. And the stage is yours, Mariusz.
Hi, I'm Mariusz, so you would remember my name. And I'm going to give a short introduction about Gradle, later CocoaPods, so you would know what we're talking about. And probably you're familiar with this situation. You're a happy React Native developer. You're writing the TypeScript, JavaScript code for many platforms. And then you want to finally build your app, the Android app, and then something like this happens. Yeah, build failed. And then get more help at Gradle.org. So you're not really happy about it. And here we are. So what actually is Gradle? What is it used for? Basically, it's the default build tool for Android apps. And it's been with us for many years, for 15 years actually. But it's the default tool since 2013. So it's, I wouldn't say you'll meet any other build tools. They are out there, but probably you're going to meet only Gradle right now. And it's also used as a dependency management tool. It's nothing like NPM or Yarn. So yeah, dependency management you may think that it's going to be similar. It's not. And at the end, it's just code. That's, I think, very important to understand that it's just code. So if there are some problems in Gradle files, you can fix them because you know how to code. And it uses Groovy or Kotlin. Right now, the most popular is Groovy, are Groovy built Gradles, but the Kotlin ones are getting more and more popular. So it's good to know that there is also an alternative. And so just to say a couple of words about Groovy, I would say it's simplified Java. It has, actually, you can even write Java in build Gradle Groovy files, but it has some differences. For example, the def keyword is used instead of type, so you can see it right here. Also, semicolons are optional. I know it's not a big problem, but it's worth to mention. And invoking a method with parameters doesn't require brackets. So here you can see one method. It doesn't have any parameters, so you can see that it has brackets, but this is also a function. I mean, method call, and this is a parameter. But well, let's open the build Gradle. And then, yeah, there are quite a lot of them. So you may think that it's a bit problematic. So here we are to explain what they mean. Actually, there is one build Gradle that is on the top level that spreads configuration to other build Gradles. And so you can see an example of this so-called Android build Gradle here. This code is from the ExpensiConX repository. And I would like to point out one thing, that for example, here you can see something like Ext with compile SDK version. So when we go to another build Gradle, the app build Gradle, which is actual application, you can see that there is something like root project.ext.compile SDK version. So that's where it came from. Apart from this applications build Gradle, all the others that you've seen are build Gradles from NPM modules that contain native code. So each module needs the build Gradle. It's a file that defines how this module should be built, and that's why it's needed. However, there are also some other things that I could mention, some other Gradle files that we should know. For example, here you can see that there's something like project that has property and there is my app upload store file. So where does it come from? It comes from a file called Gradle properties, because there is a file where you can define some variables. Actually, it's a file where you can define basically key value pairs, but it's worth to note that it exists. Apart from that, there is a file called GradleW, or actually Gradle wrapper, which is a script, that defines, invokes, or we can say that it facilitates the build, because it starts the build of the application. Also, it makes sure that the Gradle version is correct. And if you're not sick of Gradles still, there is, for example, settings.gradle that we can say connects all the modules of the application, all the build Gradles together to create one app. But yeah, that's enough of Gradle for now. Let's go to the iOS. So you know the guy. You want to build the the iOS app. And in terminal, you can see analyzing dependencies, and then you get an error. So you're not really happy about it. And again, what are CocoaPods? Well, I would say it's a bit simpler, because it's just a dependency manager for iOS projects. And it has some similarities with NPM or Yarn. So for React Native developers, it's going to be way easier to understand how it works. It's configured in pod file in Ruby. So if you know Ruby, it's easy to also configure it when you go to the CocoaPods documentation. And there are also, of course, some files that are attached to it. The most important one is the pod file, where you may define dependencies of your iOS project. You can even see something like pod, something, path. This is where you define dependencies. Also, it's worth to mention that dependencies in the iOS world would be called pods because of CocoaPods. And there's also a bunch of some functions. I'm not going to explain that because we're not really going into details, but I can tell you that, for example, this function, use React Native, is going to add way more pods to the project. However, apart from the pod file, we have the podfile.log. It's very similar to package.json.log or yarn.log because it's going to be generated after pod install command. And it's going to be a list of all the dependencies that your iOS project is going to have. And to make things more confusing, there's also a file called manifest.log that should look exactly the same as podfile.log. So what's the difference? The difference is, you can even see that the color of it is a bit different, right? But yeah, it means that this file, this file is a file that should be a local file. Because just you can imagine a situation. You execute the pod install command. Your pods are installed. Your podfile.log gets modified or generated. And then you also get manifest.log. But then you pull changes from remote repository. And it turns out that that podfile.log has changed. So during the build process, iOS is going to detect if podfile.log and manifest.log differ, and if they differ, an error is going to be thrown telling you that you should execute the pod install command. And there is also a set of files that are called pod specs. Well, it's pretty simple. It's just like a information plaque about iOS dependencies, from where you can get information with the name of the pod, version, homepage, and so on. And because all the iOS dependencies need to have pod specs, well, there are going to be quite a lot of them. Actually, what's interesting, there is iOS code in your node modules. It should have the pod specs. But when you build your app, and when you, of course, executed the pod install command, another set of pod specs in JSON format are going to be generated and then placed into a folder that is called local pod specs to make things even more confusing. But yeah, there are quite a lot of them. In fact, it's not so difficult when you get that. It's also important to know that those files exist. In fact, you probably won't use pod specs since you won't write pod specs because they are used mostly in libraries that you want to publish. But then I'm going to pass this to Michał.
Thank you very much. I'm afraid I don't have such good memes on my presentation, but maybe some little bit more inside knowledge about how those work. Yeah, so let's prepare to go a little bit deeper. So Mariusz already mentioned that in build Gradle files, you basically can declare your dependencies. And maybe that's not very popular to do that because you usually do that in package.json file, but if you need that, it's how it's done. So just to understand that this is just simply code, even though it might look like a little bit like JSON file at the beginning, it's nothing like it, because basically dependencies is just a method that takes a closure as a parameter. Closure is something in between lambda function and object in Gradle. You can think of it as sort of lambda function on steroids with some methods injected into it. And those methods are, for example, implementation or annotation processor. Annotation processor, we shouldn't care too much about that, but implementation method is the one that actually adds the dependency to your code base, and it takes one parameter, which is actually the name of the dependency in quite specific for Android format, which is like first the package, then the dependency name, and then its version. But it can get much more complicated than that. Like this is an example from the documentation. You see the implementation method being called with first parameter as, which is a name of the dependency, and the second is a closure again. And inside this closure, we execute quite a few methods. And they say, like, for example, that the version should be strictly 3.1, that the dependency should exclude some modules. So you can actually add not whole dependency, but only parts of them to your code. That might be useful when you have some conflicts between versions of files in your native code. And what about CocoaPods and pod file? It's pretty similar, maybe not as complicated, but not as powerful at the same time. You got this target, and this is also taken from your repository. So, for example, you have your new Expensify target, and you can execute a code block against this target. So code block is also kind of like a lambda function, and you execute pod method and pass two parameters to that, which is name and version of library. Version also can get a little bit more, I didn't know I will have a pointer. Version also can be a little bit more complicated, like some basic arithmetics and this optimistic operator, which tells you on which level you can bump a version without you declaring it strictly. So yeah, but you might wonder, okay, I'm not Java nor Swift developer. I'm also not TypeScript developer, JavaScript developer. So why should I care? So I think there are several reasons to care, actually. First thing is that's simply good to know. Actually, ultimately, you are building native applications. So if something goes wrong, this knowledge might come in handy, especially while reading Stack Overflow answers to your compiler errors. The more you understand, the more likely you get your answers right. But in fact, most of this is handled by those lines of codes. Mariusz already showed you this use React Native code from pod file. There's something very similar on Android side. Basically, React Native CLI takes care of that for you. So it scans through your node modules, look for native modules, and adds them either as pods on iOS or as native modules on Android. But if you were to add some dependency to only one platform, and probably there's no React Native bridge for that, this is when this knowledge may be useful. Also, the fact that those files are code actually can be profitable in some instances. Like I will show you what you can do, especially on Android side. Because Gradle is for both dependency management and build, it's a little bit more complicated, but at the same time, much more powerful. So for example, this is taken from your repository again. There's this method inside build types and debug scope, which is called build config field, and it takes two parameters, basically key and value. And as you said, you are treating it very strictly. That value doesn't have to be value. I hope you know that. But then it gets translated into Java file, which is called build config.json, I believe, .java, sorry, and you can access this file, these values from your Java or Kotlin code, and for example, expose it to your JavaScript code in React Native. And for example, you can make some fields based on your build configuration or on your environmental variables. Actually, sky's the limit. You can use it as you please. Another good example that is pretty commonly used in Android world is reading some files from your file system. Like for example, you can access package.json, parse it to the JSON object, and then use some fields from there to unify, for example, versions between package.json and native files, so that you then only need to bump version in one place. You can, of course, add some scripting to that, but maybe the scripting isn't really needed if you configure your build Gradles properly. And yeah, there is one word missing from our presentation title, and it's CMake. And maybe some of you is wondering, what is CMake anyway? Me too. So let's just ask this guy. He tends to have very long responses, so let's limit him. What is CMake anyway? Nice! Live demos, right? Okay, so I guess I will need to try and memorize the last response I read from him. So basically, CMake is a tool to build pretty much any library on any operating system and on any architecture. It uses those CMake list.txt files, and in our universe, it's being used to build native libraries inside of Android, mostly Android ecosystem, because iOS is a little bit different and it doesn't need that much. But anyway, if you are to build native libraries, and by native in this, like there are various layers of native. It's not native like Java or Kotlin native, it's like C, C++, or no, I don't know, Rust native. So if you are to build some C, C++ code inside of your Android project, then you can use this external native build method, then a CMake method, and pass some arguments. They basically tell which projects to build. And you can see that, for example, React Android is being built with CMake when your Android application is built. Okay, so let's get some more shit done. Like, for example, there is one very cool feature of Gradle that I would really like everyone to know about and to use much more across the board, because it's used in Android world a lot and not that much in React Native world, and it's flavors. Why am I even bringing that up? So basically, in your code base, you've got this something called build types, which defines 4 types of build you can execute with your application. It's some debug, release, end-to-end release, and internal release. And I like that. Like that's fine. But with flavors, you can get rid of it, with at least of some of them, and get that a little bit more sophisticated. Because what you got is pretty okay, but quite poor. So what? Let me pause for a while here. This is list of changelog in React Native 71. So you might have missed that, but there is, in this version, there is a section added. And in this section, there's an addition by Nicola Corti, which says added flavor support to React Native grade tagging. That's exactly what we were talking about, because back then, and when up to React Native 70, it was doable to use flavors, but not very easy. Now it's very straightforward, and it just works. So let's do this rich configuration. Let's leave rich, why not? And we can define something like flavors in our build Gradle file. It will be our application build Gradle. So basically what you do, you define your dimensions. So let's think of this as of n-dimensional array. So first dimension is your build type, and second dimensions are flavors. So let's define one dimension for us, and let's define dimension called distribution and two flavors within this dimension. It's QA and internal. And what you can do, you can do a bunch of stuff here, but just for to show you how powerful it can be, you can add, for example, application suffix to that. What does it mean? It means that you can have version of your application that is installed in parallel on your application. So another application ID, there cannot be two applications on your phone with the same application ID. But if you add suffix, you can have them. So you could have potentially a staging and production application installed on your phone at the same time, thanks to that. Also, we can have version name suffix, like for example, for some crash monitoring or stuff, so that you know that this crash comes from this version, but it's much, much more than that. And thanks to that, you can, for example, with addition, if we treat that as addition to our build types, let's remember we removed those two, so we got only debug and release build type, and this is our rich two-dimensional array of potential build type, of potential flavors / build types that we can build. And we can add to both dimensions of those, and we can add dimensions to that. So for example, we can make free or paid version. We can make, I don't know, a version that is on some older, specifically for some older phones, and so on and so forth. And they can all differ in various aspects. And actually, it's up to you, to us, to come up with good solutions. How can we leverage that? But I believe it can be leveraged pretty nicely. And there's one very powerful tool to flavors. It's the same as for build types. We are using it a bit, but I don't know if you realize the full potential of it. So basically, this is your repository structure. There's this Android directory. There's this app module inside of it. And there's this SRC, which basically contains all native code and assets and configuration. And you see that there's main folder, which is basically main code, assets, and configuration. But we can add, for example, debug folder or QA release folder. So QA release, remember, QA is our flavor, release is our build type. And basically what it does, it merges those folders into one during build time. So you can substitute some drawables, for example, for a particular flavor. So for example, you can have different icon for your QA flavor so that you can differentiate that on your phone. Or you can change Android manifest, which will be merged pretty nicely. You doesn't have to have whole Android manifest in all those places. Unless you avoid conflicts, like the nodes will be merged very nicely. This tool is pretty smart. So for example, you can add some service or some external library configuration for only this particular flavor and build type. You can also substitute your Java files per flavor. So there's no limit to that. Like actually you can do pretty much everything. Sky's the limit and our imagination is the limit here. But what about iOS? It must have something similar, right? And it doesn't. Like, I mean, it kind of does, but it's not near as powerful and not near as useful. I mean, there are targets and build schemes which you can achieve pretty much all of what I said, but it's in all those different places. Like some of those are configured by adding like files per target, but you cannot really do everything per build scheme. Basically, targets shouldn't be used for that, but it is used for that in many instances because it's much more powerful. Yeah, so yeah, iOS, get your shit together. And yeah, any questions? I will take a look at our chat first. Yeah, there's one. Big fan of matching outfit with the presentation background, Mariusz, 10 out of 10.
Yeah, actually, well,
that was intended.
Yeah, but we should use the pink hoodies.
Sorry, I don't have one. Okay, any questions? Go ahead.
What's changed is 71 of flavors. I remember using them for a while now.
Sorry, once again?
What's new in 71?
Okay, so the question is what's new in 71 for flavors? So I don't know of all the changes, but basically the most important and significant change that I noticed is that you can add in build Gradle, there's a predefined configuration that you can add which flavors should have your JavaScript code embedded into build. And prior to that, it was doable to differentiate which should have embedded and which should have Metro bundler, but it wasn't really supported per se, so it was causing a lot of problems. This is most notable change. I haven't looked into whole PR so deeply, but yeah. Go ahead.
Have you ever tried to set up like parallel Gradle builds in a React Native app?
Have I ever tried to sell parallel Gradle builds in React Native app? Unfortunately, no, I haven't. Sorry.
I'm curious for some more details on how auto-linking works, specifically maybe from when I run npm install, but then also from maybe a developer perspective writing a library. Like, do I include a build Gradle on the CocoaPod spec in my source library?
Yeah, so the question was how auto-linking works, especially from the perspective of libraries developers. So basically, if you are creating a library that is purely TypeScript or purely JavaScript, you don't have to. If you have native code, then you do, but there are templates for that. Basically, in most cases, you don't really need to do much with those templates. Potentially, you might want to add dependencies, as we showed you with those implementation and pod methods, but most of the time, that's pretty much it, because the templates are pretty good. And how it works, I guess I can skim through in very, very, very little details. So basically, auto-linking script goes through pretty much every directory of your node modules, and it tries to determine, if I'm wrong, then software mention team correct me, because some of you might know better. But basically, it tries to determine whether each and every node module has a native code. In older versions, it did that by looking for specific files. Now it can also be done with some JSON file. I don't remember the name, React Native config or something like that, .json, which declares which native modules are part of this node module. But I guess the old way still works for legacy reasons. And yeah, and it basically does it for you. So once you install it in Yarn add-on or npm add, it just gets done. On iOS, you need to execute pod install. On Android, you don't have, because as we said, on Android, Gradle does two things at the same time. On iOS, those are two separate tools, one for dependency, which is CocoaPods, and one for building, which is Xcode build.
Yeah, those scripts are also available on the open source. So
yeah.
There's, for iOS, I think, React Native pods file, so you can even see the code, what's getting executed.
It's not that complicated. Go ahead.
Is there some way to just make it automatic and not have to run pod install like you said, Android works out the box with the same install, and you don't have to pay anything, build it out. And why can't we find a way to do the same with iOS?
I'm not really sure. Like, I guess the main difference is in approach. Like, because CocoaPods, as Mariusz said, works pretty similarly to Yarn, so they just handle dependencies for you, and actually nothing more than that.
Maybe, I'm not sure, but in the iOS world, there is, many iOS developers believe that the pods should be also pushed to remote the repository, so maybe that was some kind of an assumption that
that would be similar to pushing node modules to your repository.
Yeah,
but they do that. They do that. Yeah, iOS developers get your shit together.
But we are React Native. But we are React Native developers, so we don't do it.
Yeah, and anyway, I guess it's kind of difference in approach because of that approach in Android. Builds might be a little bit slower because even though you know nothing changes in your dependencies, it must be analyzed every time pretty much. There's no log file as well. There's no pods or node modules file. Like those approaches are so difficult. I can't think of why would it be wrong to execute those automatically with your build, except for a little bit slowing the builds down, but maybe there are some reasons.
Maybe because maybe about the performance, yeah. Because when you want to build the Android app and nothing's changed, it takes like 1 second. Maybe it's a performance issue with executing pod install.
So the question is about pod install being failing after M1s is being introduced, and whether NPX pod install should or is fixing that. Honestly, I don't know. I haven't moved to M1 yet, but as far as I know, when you start a new application, React Native application, there's an already bunch of code in your pod file that is basically fixing that for you.
And there is something applied to the pod file that is fixing that. But I personally, because I use an M1 Mac, I haven't bumped into such issues for a while.
Actually, I guess there's a workaround simply added to pod files in React Native applications, and that's how it's fixed. So yeah, if you have older application, you need to still add it on your own. But basically, I guess it's also like covered in, if you just look at the newest template and you copy paste Cocoa pod file from there, then it should pretty much work for you. Okay, I guess we are out of time anyway, so if there are any more questions, then hit us up on channel and we are happy to answer them. Thank you.
Yeah, thanks a lot, guys.
Good time.
That was great.